In today's lesson, we are going to be looking at the volume of prisms and cylinders. So this does tie into a little bit of what we did yesterday, primarily with area. So before we get into our lesson, let's do a little bit of a review just to make sure we're okay with what we covered in the previous lesson, finding the area of composite figures. So what we want to do is find the missing dimensions of this garden and then determine the total area. So some easy things first, obviously with the dashes, they are the same measurement, 3.7 meters. Because this is two figures, we could technically draw a line across here to identify that this is a semicircle, and then we do have this rectangle here. By doing that, we can see that the opposite side of our rectangle is actually the same height as the other side, so 3.7. Now we need to figure out what is this missing measurement. Well, we know the entire length of the rectangle is 7.4 meters. So if we take that entire length, subtract the portion that we already know, the leftover will have to be the missing measurement for our semicircle, which in this case also works out to 3.7. So we have all of our measurements now. We have enough information to go through, find the area of our first figure, find the area of our second figure, and then we'll add them up. Area of number 1, length times width, 3.7 times 7.4. We do that, we get 27.38. It does say to the nearest tenth, so the tenth is 1 decimal place, so 27.4. And for our second area, it is a semicircle, so that is pi r squared for the circle divided by 2 for the semicircle, with 3.14 for pi multiplied by the radius. Alright, we don't have the radius yet, but the radius is half the diameter. So the radius is equal to 3.7 divided by 2, which is 1.85. So the radius is 1.85. That will be squared. Then we divide everything by 2. And we get 5.4. Now all we have to do, we have the area of each individual shape. We can add them up. 27.4 plus 5.4. And we get a final total area of 32.8 meters squared. So for volume and prisms, recall from grade 9 that a prism is a three-dimensional shape consisting of congruent shapes for the base and top. So these bases may be triangles, rectangles, circles, and so on, and it has rectangular sides. So if I look through these three different prisms and the two prisms in one cylinder, we can see that they have the same or congruent. Oops, if I can draw better on the bottom. Congruent shapes. Congruent just means the same. So they have the same shape on the top and the bottom. And the shapes on the top and the bottom tend to be these basic shapes that we looked at in the previous unit. Your rectangles, your triangles, your circles. So in each case of each prism and cylinder, the volume is calculated by a general formula, which is volume is equal to the area of the base times the height. So it doesn't matter what your prism is or what your cylinder is, as long as you can find the area of the base, you can multiply that by the height and you will find the volume. The nice thing is, we know the area formulas for a lot of these basic shapes. Length times width for a rectangle, base times height divided by 2 for the triangle, pi r squared for the circle. So even though we know the formulas for these basic shapes, we can definitely find the volume. The same basic principles apply to any sort of prism, even if it's not your standard rectangular prism. As long as you can find the area of the base and multiply it by the height, you can find the volume. Keep in mind as well, when we talk about bases, those are the two same shapes or congruent shapes at each end, no matter how it's oriented. So if I have my cylinder, I can see that I have a circle on one end, a circle on another. It doesn't matter how I rotate it, I have those shapes there, those congruent shapes there. So let's take a look at the first example. So a chocolate candy mold is in the shape of a triangular prism, which we see here, and that's used to make a centerpiece. It takes 270 cubic inches of chocolate to fill the mold. How tall will the chocolate centerpiece be? So we need to find this missing measurement. We want to find out, what does this work out to? What is this height? Well, what information do we know? We know it's a triangular prism, and we know that it takes 270 cubic inches to fill the mold. So we're actually already told the volume. So what do we do next? What else do we need? Well, because we're dealing with volume, we probably want the volume formula. So in the volume formula, in our case, is the area of the base multiplied by the height. Well, we don't know the height, but we do know the area of the base. Right? The area of the base is the area of this triangle. And we have enough information to find that area. Right? So if I find the area of that base, because it's a triangle, base times height divided by 2. So in this case, 4 1/4 inch is basically 4.25. That is actually considered my height. So actually, let me erase that and we'll put it second. We'll start with the base down here. 8 3/4 of an inch, or 8.75. Multiplied by the height of my triangle or my base, which is 4 1/4 or 4.25, and then I divide by 2. You should find that we have an area of 18.6 inches squared. Now I can use all this information that I have to find out what that height is. And I can do that by plugging in the information I know into this general formula for volume. I know the volume is 270. I know the area of the base is 18.6. And I know that I need to multiply that 18.6 by a number in order to find my volume, or get my volume. So what we need to do then, we need to solve this equation. Well, how do we solve this equation? What do we do? Well, in order to solve the equation, we need to isolate or get h by itself. How do we do that? Hopefully you remember from grade 11 and 10 and 9, but we do the opposite operation, or we cancel things out. If I want to cancel out this multiplying by 18.6 so that h is alone, I need to do the opposite, or divide by 18.6. Now, in order to make sure that I haven't changed my equation, I need to do the same thing to the other side. I need to divide the other side by 18.6. One side will cancel out, and I'm left with 14.5 inches for my height. So now I know that the height of my centerpiece is 14.5 inches. So therefore, the height is 14.5 inches tall. Oh, just the height is 14.5 inches. Good. So again, a little bit different of a volume question, but hopefully you're still able to go through and kind of figure it out, or at least you see how we figured it out. Example 2, the swimming pool is filled at a rate of 1.25 cubic feet per minute. How long will it take to fill? Well, this is an odd looking prism. It's not one of our standard prisms that we've dealt with, right? It's not a rectangular prism, it's not a square or a triangular prism, it's definitely not a cylinder. So how can we figure out the volume of this pool in order to figure out how long it will take to fill? Well, let's think about our general formula. The volume is equal to the area of the base times the height. Do I have, or what is the base of my pool? You might say, well, the base is the bottom. What are we talking about? It's the bottom. It's this section, this slanted section, and this shallow end. You might be right. In general terms, that is our base. But if we consider this a 3D object, if we consider this pool a prism of some sort, what would the base be? Remember, the base is the two sides that are congruent or the same no matter how you rotate or orientate your shape. So if I was to take this pool, imagine holding this 3D model in your hand and you're rotating it around, which two sides are always going to stay the same? And you should find, or you should recognize, that this side is the exact same on the other side. So even though this isn't our traditional prism, we hopefully can still see that there is two congruent bases with rectangular sides. Right? We have these rectangular sides on either end. So this is actually a composite figure or composite shape where we need to find the area or the volume for. We have the base, so if I were to take a cross section or basically look at this in 2 dimensions, this base here actually looks something similar to this. Again, you'll have to forgive some of my art skills, but that is essentially what our base looks like. And can we find the area of this shape? We can actually. We can find the area of this shape. Now, there's different ways that you can do this. Again, different ways you can divide this figure up. Right? You could look at it as, well, there's a rectangle here, there's a triangle here, there's a larger rectangle there. You can definitely do that. You might say, well, there's a larger rectangle here, and I'm going to cut out this triangle, and then there's a smaller rectangle. You can definitely do that as well. In different combinations where you maybe go across here and down. So again, you're still having 3 figures. Again, it's up to you how you divide it up. Just make sure you're dividing it up properly. Let's kind of mix it up. I'm going to draw a rectangle as such. So that will be my figure 1. I have figure 2 over here. And I am going to subtract this little triangle or figure 3. So now I have 3 different areas that I need to find. So the area of my first shape, rectangle, length times width. this case, if I go back to my measurements, 8 by, well, this is interesting. How long would that be? I know that just this bottom part from here to here is 12. But what about this difference? Well, if I go back to this original figure over here, I know that up here, so I know that's 12, I know that's 8. I know this portion is 10, this thing is 12, and the entire distance is 32 on the top. So 12 and 10 and this missing piece here, from here to here, would have to add up to 32. The only number that works is 10, or you could do 32 minus 12 minus 10, leaves you with 10. So that means for my rectangle, the entire base from here to here is actually 22. So the area of this rectangle is 22 times 8, which gives me 176 feet squared. The area of my smaller rectangle is 10 by 4, or 40 square feet. And this third one, the one I'm going to be removing, area of this rectangle is base times height divided by 2. I have my base of 10. Oops, I don't have my height. Luckily though, I have enough information to find it. The entire height is 8 of the pool. This little section is 4, so that means that this distance from the top of the slope to the bottom would have to be 4 as well. So 10 times 4 divided by 2 gives me 20 square feet. Now that I have all that, I can find the total area, right? Because our goal is to find the total area of this base. So 176 plus 40 minus 20, right? We're subtracting this triangle here. We do add all that together, we should get 196 square feet. So if we were just finding the area of this composite shape, we'd be done. But we're actually trying to find the volume. So I need to go back up to this original formula. The volume equals the area of the base times the height. So in this case, I now have the area of the base, 196 square feet. I'm going to multiply this now by my height. So what is the height of my prism here? I use quotation marks there, air quotes, right? Because it's not our common prism. Well, what is the distance from one side of from one base to another? Well, the distance is 16 feet. So we can argue that our height of this prism, or obviously not our traditional prism, our height is 16. So this is actually referring to our height, even though you might argue that it's the length, right? In terms of a prism, it would be considered our height from one side of the base to the other. So for the volume, the total volume is 196, the area of the base, multiplied by the height, which is 16, and we should find that it is 336 cubic feet for our pool. So our pool has a volume of 3,136 cubic feet. Now I want to figure out how long does it take to fill up. Well, in order to figure that out, we have our entire volume. We're going to divide it by how much I can fill per minute. And when we divide the two, you get 2,508.8 minutes. So it takes quite a long time to fill up this pool. But if you think of this as feet, it is a 32-foot pool. That is quite a large pool. And it is 8 feet deep in the deep end, so again, it's not a shallow pool either. Our last question, a little bit straightforward. Calculate the volume of the following cylinder. So nothing too fancy about this. Volume of a cylinder, right? That is the area of the base times the height. Yes, your formula sheet has a different formula, but it breaks it down to giving us the actual formula. Because if I look at the base, well, what's the base? Right, we talked about cylinder. Base is a circle. What's the area of a circle? Pi r squared. So pi r squared multiplied by h, that's the formula you probably see on your formula sheet. Pi is 3.14 times the radius squared, so times 3 squared, times 10, or the height. 3.14 times 9 times 10. We end up with 282.6 centimeters cubed. So, again, that one was straightforward, but as long as we can find the area of the base and we have the height, we should be able to find the volume of a prism or a cylinder. Keep in mind, in some cases when we have complex shapes, as we saw in example 2, we can still find the volume using our knowledge of composite figures, and as long as it fits the standard definition of a prism, we should be able to find the volume. Now again, it fits the definition by having congruent shapes on either end for the base, even though it may not look like your standard prism that we're kind of used to. But again, as long as you know kind of those basics, we should be able to find the volume of technically any prism now.